This conference will now be recorded.
Good afternoon, students. I will wait 5 minutes. Let them to join. Right. Let them to join. So in today's class, we are going to discuss about optimum generation allocation with including transmission losses. See, already I said that I already told that the scheduling process including three methods. One is normal traditional method, and second one is analytical method with neglecting losses. In that we have two cases. In the two cases, one is including generating limits and not including generating limits. And third one is it is also underwriting method, but here we are including the transmission losses. See, what is the difference between second one and third one? Third one means, so both are optimal allocation, and these methods are using for the scheduling. But the difference is we are not including the transmission losses. And you have one doubt, right? When we can consider transmission losses, when we are not considering the transmission losses means, suppose if the load is nearer to the generating station, so there is completely negligible losses will be happening there. So why? Because the transmission losses should be depends on them how much of distance is between that generation and that is the load. So when the load is nearer to the generating station, so the distance should be less, right? So at that time we are not considering the transmission losses. And when we consider the transmission loss means when the load is highly far away from the generating station, it means it will be located far away, that is more than 100 kilometers. There we can consider the transmission losses. And what is the difference between in these two in performance point of view means, if we are not considering the transmission losses, so we can't able to find that exact performance of a particular plant. But if we considering the transmission lines including the equation, then we can know that which plant having that better performance than others. So that is the difference between these two. That is one is derivation is not including the transmission losses, and second one is including transmission losses. So this is the topic we are going to discuss in today's class. And these two very most important questions from first unit. So they will ask any derivation or problem based on these two topics. One is including losses and not including transmission losses. So you should aware about these two topics. Then you can attend the questions from the first unit. Now let me go for a topic and discussion how we can. So this is also derivation part. Just keep note on the equations. Then only you can understand that step by step method. If you have any doubt in between that, just clarify in this class itself. Then only you can understand that. So today's topic is optimum generation allocation with including losses. So the same sentence we can say in alternative itself, that is economic dispatch scheduling with including losses. So both are same. So don't confuse that. Economic scheduling is the same. Economic is nothing but a less losses in the cost oriented. So that is the called economic dispatch, right? So both are same. So let me go for the topic. See here, I already told that When the distance of a transmission line is very small and the load density is very high, transmission losses may be neglected and optimal dispatch of generation is achieved with all plants operating at equal incremental production cost. So this is the sentence is belongs to the that is a method one. So in that time we are equating the all incremental production cost. So incremental production cost is denoted by lambda, right? So in the first case, we are equating that all lambda 1 equals to lambda 2. So that is the incremental cost we are equating, and finally we are finding that PG, what is the value of PG1, PG2. So this is in this type of conditions we are not considering that any transmission losses. So it is completely negligible. But when the power is transmitted over a long distance distance, the transmission losses are major factor. So that is the reason why we are the transmission lines having that fax device. So this is the reason. So the main purpose of fax device is used to reduce the transmission losses by compensating. So if some voltage drop will be occur due to the losses, that voltage level should be compensated by the fax device. That is the purpose of fax device we are placing in the long transmission lines. And if you minimize the losses in the transmission line, then only you can save the money. So if the power system operation is completely main concentration on cost. So how much of cost it is required for generating, how much of cost it is required for the transmitting, how much of cost it is required for the distribution. So based on the cost itself, you can say that the particular sector is a economical or not. So that is the main concentration as belongs to the cost oriented. Now, in this reason, in this case, we are including the losses and finally finding that what is the power generation to rectify the load demand by including the losses. That is our main agenda in this derivation. Now let me go for one by one. So in this condition, the common practice for including the effect of transmission losses, it is in the form of quadratic function, and this is the power loss. So power loss expression, PL is nothing but a power loss expression, because we are including the losses here, right? So that's why this equation is including in this. But last derivation we are not considering here because there is no transmission losses. So this equation is called as power loss equation, and it is in the form of simply quadratic form. So why it is called as quadratic form is, suppose in a equation any two parameters are involving together, then it is called as quadratic equation. Suppose just simply we can say x square plus 2x plus, so here the second order term, so it means that the two variables are including in that equation. So if you simplify that x square plus 2x plus something, then you will get the two roots, right? So two roots in the sense two factors are acting at a equation. That's why it is called as simply quadratic form. Now in this equation, the Bij is called as loss coefficient or B coefficient. So it is a very important for 2 marks. Write down the equation of loss formula and mention that what are the parameters using in that loss formula. So here Pi, that is power generation with respect to the ith plant, Pj power generation with respect to the jth plant, and Bij loss coefficient with respect to the both. So when we combine these two, based on that how much of loss will be power is losing with respect to these two plants. So that is the equation we are considering here, and this equation is called as power loss equation. Next we go for next slide. So I think you guys are clear about why we are using the including losses criteria in this derivation, because this type of scheduling is useful for the long distance transmission lines, and here they are including the losses for the economical purpose. So if they know the losses itself, they can easily find out that how much of cost is required for the particular transmission. Right. See, in last derivation, we used some methods that is formed the Lagrange formula. Same thing here also. The loss formula can be represented in another way, that is called as Cron's loss. So from this unit, you will get 2 marks means last, that is power loss equation, or write down the Cron's loss formula and what are the terms is including in that. So this equation is called as Cron's last formula. So Cron's last formula, why it is called as Cron's? So this is the scientist name. And what is the difference between our previous one? This one means it includes standard term, that is constant term, and linear term. So linear constant term. So constant term means there is no need to change any parameter. So it is fixed value. But linear term is one parameter should be related to the other parameter. Suppose if we take resistor, so resistor we have the linear characteristic, right? So in that the VI characteristic should be linear. It means that one voltage should be depends on, so both are interrelated to each other. The same thing here, the linear term and constant term we are referred here, and this first term is called as linear term and second term is called as constant term. Why it is called a linear term means here the both, this is the set of generation, that is belongs to the ith plant and this is jth plant. Well, combining these two, the character should be in the linear. So both are should be linear working together. Then only the system should be in stable condition. So these two combination is called as Cron's last formula, and it consists of linear term and constant term. So here the first term is called as linear term and second term is called as constant term. So up to now it is a new for you. Why? Because these two formulas we didn't use it in the last derivation. But upcoming formulas, what we derived, what we discussed in the last derivation, you will get in that. Now, so this is the last formula. Why? Because we are main concentration on losses only, right? So we found that two last formulas. One is that is the quadratic, in the form of quadratic equation, and second one is in the form of cross loss, and it consists of two terms. One is linear term and the constant term. Now, the economic dispatch. So economic in the self, we are forming the equation in terms of cost oriented. So already we know the cost equation. So if you expand this equation, Ct is equals to, so suppose if we have the plant having the 3 units, then you will get Ct is equals to C1 plus C2 plus C3. So this is the meaning of this equation. And here the Ci, the cost of ith plant. And if you term in the representation of constant parameters, it will get alpha I plus beta I Pi. So sometimes I am notating PGI or PI. So both are same. Don't confuse them, right? So PGI is same as PA. So alpha I plus beta I Pi plus gamma I P2 P square I. Now this is the total cost equation. Now from this equation, if I want to find the incremental, that is lambda, what we have to do? We have to differentiate this equation with respect to the PA. Then only you will get beta I plus 2 gamma I PA. So this is Ct is a total cost equation and lambda is the incremental cost equation. Don't forget that. Incremental in the sense we have to differentiate with respect to the power generation of ith plant. So this is the cost equation. Represent it is equation 3. So till now 3 equations are over. Now from this equation, so see here, the power generation of all generating unit is equal to the power demand plus power losses, and it is also known as power balance equation. So how much of power is, so what is the requirement of power generation is completely depends on how much of power is demanded and losses. Suppose your power demand is 400 and your power loss is 100, and the generator should generate 500. Why? Because it should satisfy the losses, then only they can satisfy the demand. So this is the power balance equation. So this is also you will get 2 marks. Write down the power balance equation in the optimal economic scheduling. So that is a summation of I equals to 1 to Ng, Pi is equals to Pd plus Pi. So here Pi is nothing but a power generation with respect to the ith plant. Suppose if one is P1, P2 like that. So the generation should equals to the power demand plus power losses. So this is equation 4 and it is called as energy balanced equation. And after finding this value, the generation should satisfy this equality constraints. So already we did the problem on this. So if you find that power generation by the plant, it has the generated limits, the value should within the limits itself. If it is not within the limits, we have 2 conditions. Suppose if the P1 is less than minimum value, you have to consider that this value. If the P1 is more than the maximum value, you have to consider the maximum value. So this is called as equality constraints, and it should be satisfied. So if it is satisfied itself, then you can say that the particular plant is working in proper way. Why? Because every device having that minimum and maximum performance ratings. If it is if it is exceeded within the limits, then there is some drawbacks. Then is some problem is occurring in the particular machine. So that is the indication of maximum and minimum. So this is called as equality constraints. So now by using Lagrange multiplier. So this formula we already seen in the last derivation, that is not including the transmission losses. But the difference is there we are not considering this term PL. So just we considering. So in that case, the power balance equation is the power demand is equals to generation. So this is called a power energy balance equation in the case of not including the transmission losses. But in this case, we are considering the transmission losses. So the balanced equation is become like this. Now from this equation, when this term should be beings like this, then it will be equals to PD plus P. So you will get like this, and the total equation we will get from the Lagrange multiplier. L is equals to CT plus lambda into PD plus PL. So this term is completely called as energy balance equation. While doing the problem, you should satisfy this equation, and it should be equals to the 0. Then only you can your assumption of lambda value is correct. So we already did some problems when lambda equals to 6. If it is not equals to 0, then again we are updating the lambda. So we'll keep on going to checking that until when we are applying the 0 value. So 0 value means the demand plus losses minus generation, then you will get the 0. At that condition, we can consider the lambda value is a perfect value for the scheduling process. And this is for obtained from the Lagrange multiplier, and this equation is denoted by sixth equation. So until now, we formed the different equations based on that what we have to find in the upcoming derivation part. The first one is we formed the power loss equation in the two ways. One is quadratic form, another one is Kranz loss formula. It has the two terms. One is linear term and constant term. After that, we found that energy balanced equation. So after that, we have cost equation. So equality constant equation. Finally, we found the equation by Lagrange multiplier. So these are the 6 equations. You have to remember that. If you remember the 6, then the entire derivation will be easy. If you forget any equation, then it makes it difficult to you. So next, go for next slide. So same thing what we did in the previous derivation, here also we have to solve in 2 cases, 2 conditions. The case one, the condition 1 is we have to differentiate that Lagrangian equation with respect to the PGA, and it is equal to 0. At the same time, we have to differentiate Lagrange equation with respect to lambda and equals. So we have to derive in 2 conditions. So already we have the Lagrange equation, right? CT plus lambda PD plus PL minus summation of PI. So this is the equation of Lagrange's equation. Now for this equation, we have to solve in these 2 conditions. One is when this equation is differentiated with respect to the PGI and it is equal to 0. And second condition is when this equation is differentiated with respect to the lambda and is equal to. So this is called as partial differentiation with respect to the different variables including in this equation. Now we'll go for condition 1, condition 2. Let me see what will happen here. So this is the, just note on these 2 conditions. So this is the main part of this derivation. So if you solve the entire derivation, it depends on these 2 conditions. So one is dou lambda by dou Pj and is equals to 0, and dou L by dou lambda is equals to 0. Right. Now the condition 1. So just I'm writing the Lagrange equation. L is equals to CT plus lambda into PD plus PL minus summation of pi or pg, whatever it may be. So this is the Lagrange equation. Now what is our condition? We have to differentiate Lagrange equation with respect to the dou pi or pga, whatever it may be. Now if you differentiate with respect to the pgi, like condition 1, you will get dou ct by dou pgi plus lambda into, here pd is a constant term, so power demand, so I need this much of power, so it should never be changed, right? But power power losses will be changed based on the environment, so it is not in our human hand, but the demand is fixed value, that's why we are considering as constant and it becomes to zero. And power losses keep on changing based on that environmental condition, based on the malfunction of transmission line parameters, what, so this, that's why we are we are considering here. And minus of, we are it should be equals to 1 and equals to 0. Now this cost ct is equals to the c1 c2, so this is the total cost of the plant of the unit. Now from this equation what you will get means, so if it becomes dou L by, so this is the cost, this is the cost equation with respect to the total cost and the CI. Suppose we are considering the, if it is have the only one plant, then you will get CT is equals to CI. So this is the equality terms with respect to the total cost and cost for the ith plant. Now I am substituting instead of this term by DCI in this equation. So therefore, so it should be equal to 0, right? So from this DCTI DPJ, instead of this plus, I am placing that dou CA by dou PGI plus lambda into 0 0 plus lambda into dou PL by dou PGI minus lambda equals to 0. From this we found that lambda value. This is called as incremental fuel cost, right? Now, in this equation, the term dou PL by dou PJ is known as incremental transmission loss. In this, so this is the combination of two terms. One is, this is called as incremental fuel cost. So incremental fuel, if you did this, solve this equation, you will get beta I plus 2 gamma I PJ. So this term is called as incremental fuel cost, and this term is called as incremental transmission loss. So that is the difference between that what we discussed in last derivation. So in last derivation we have only this term. So lambda equals to, so lambda equals to only this term we have. Why? Because there is no losses. But in this case we have the two terms. In the two terms it is including that incremental fuel cost as well as incremental transmission loss. Just keep remembering that incremental fuel cost is dou C by dou CI by dou PGI, and incremental transmission loss is dou PL. So PL is a transmission loss, right? So dou PL with respect to the dou PGI. So this is the two terms including the lambda, and it is denoted by equation 9. So this is the condition. So in condition 1 we found the lambda, and this lambda is consists of two terms. One is incremental fuel cost, another one is incremental transmission loss. Next, condition 2. So what is our condition 2? We have to differentiate Lagrange equation with respect to the lambda. So again, so this is the equation of L, and we have to differentiate this equation with respect to lambda. What you will get? This term becomes 0, and it will become 1, and finally we will get the equation like this. So PD plus PL minus this one equals to 0. Finally, we will get that power balance equation. So this is the condition 2. We derive that equation that is called as energy balanced equation or power balance equation. Now by using these two conditions, we are going to derive that what is the power balance equation. We have to going to schedule the particular plant. Right. Now from equation 9 we rearranged for lambda. So this is the equation we obtained from the case 1. That is when we differentiate L with respect to the dou PGA. From this we got this formula. So this is the incremental fuel cost, and it is the incremental transmission loss formula. Now from this equation I need I need the Li value. That is the what is the value of, so here one factor will come. So let me see how it will come. So consider this equation lambda. So this from this equation, bring this lambda term in left side, then take the common lambda, then you will get 1 minus dou pl. So pl is power loss, dou pg is equals to dou ci by dou pga. From this lambda is equals to this entire term brings to denominator here, so 1 divided by 1 minus dou pl divided by dou pga. See here, this term is denoted by the li, and li is called as penalty factor. So this is also one of the most important for 2 marks. Write down the penalty factor for a ith plant. You have to write like this. So Li is equals to 1 divided by 1 minus dou PL by dou PJ. So this, what is the need of this derivation means we have to find the penalty factor. So if you find the penalty factor, in the sense we can find that how much of losses is happening within the generation itself. So generally in generation we are generating the 100 megawatts and transmitting and delivering the load, but we are concentrating on what are the losses happening in the transmission line itself, but we are not considering the generation, and these losses should be determined by with respect to the penalty factor of a plant. And this factor says gives the information how much of losses will be happening within the plant itself. So that is the use of penalty factor. For this factor itself, I only derive this equation by using the ninth equation, and by using this lambda. From this I supposed to derive that penalty factor here. Now we go for next slide. So are you clear about this penalty factor? So just this equation is only for penalty factor. For that only I again derived here, arranged here. Next, the incremental production cost is given by. So incremental production cost is nothing but a incremental fuel cost. So that is dou C by dou PJ. So generally the CI formula is CI is equals to alpha I plus beta I PGI plus gamma I PGI square. If this is the normal cost equation, if you want to find the incremental cost equation, you should have to differentiate this equation with respect to PA. The same thing I did here. Dou CI by dou PJ, you will get beta I plus 2 gamma I PJ. So this is already you know the equation how it came. Now the incremental transmission loss is obtained from equation 2. So we have the equation 2, right? That is the Kranz loss formula. From this equation, the same. So this is the, we have the lambda is the combination of incremental production cost plus incremental transmission loss. So we have to substitute these two terms here. That's why I'm deriving here. So this is the first term, and second term is incremental transmission loss. In that, how we can obtain means if you differentiate that equation 2 with respect to pi, you will get 2. So why the 2 will come means it has it is a combination of two plants. So we have to separate, we have to find that 2. So plant 1 and plant 2, and unit 1, unit 2. So both commonly we will get the 2 here. So 2 into Bij Pj plus Boi. So this is what this is called as a B. These terms are called as B coefficients. So these parameters not involving majorly in this derivation. So just for understanding it purpose, I am including here. So if you differentiate that equation 2 with respect to the PGI, you will get this equation 14. And if you why 2k means it has to be the equation should be formed by that two units. One is ith unit and jth unit, right? So that's why separately we have to differentiate, and after that we have to add. That's why we got 2 here. So after finding these two equations, we have to substitute these two, that is 13th and 14th equation in lambda. So lambda we have, so this is the equation we obtained previously, dou ci by dou pi plus dou pl by dou p. So this is the lambda value, and this lambda value includes incremental cost equation plus incremental transmission loss. So now these two equations we have to substitute in that. Right. So this is the lambda we have. Now already the 13th 14th equation should be substituted in this equation, that is in the place of dou c by dou pj. This is the incremental fuel cost and it is the incremental transmission loss. If you substitute these two terms in the lambda equation, you will get like this. From this, what we have to find means we have to find the pj. So if you just observe this equation, I am bringing that lambda, that is a PGI is allowed, that is PGI. So we from this equation I want to find that PGI. So for this purpose, I'm separating that summation term is separately and remaining terms are separately. From this I got this one. So here the Dij equals to Pj. So here J is not equals to I. Why? Because what is the reason is if we are using so I is separate and J is separate, right? So if we are using first plant is I and the second plant should be J, so we are not taking the two plants as the same. So that is the condition I am considering here. J is not equals to I, and referent it is equation 15. Now from this equation I just want to find that PGA. So PGA, where it is PGA here? So PJ here. So I want to find that this PJ value. So that's why I'm deriving this equation. So the PGI here, after the PGI, we will get this equation. So why? Because what is the need of this PGI means, suppose if you want to find the power generation with respect to the plant one, we have to know that all constant with respect to the lambda. So previously we have the lambda minus summation of 1 divided by some, we have some formula for PG1, right? The same thing we are using here, but here some including us are included. What are the these B coefficients for the understanding purpose? So at last these terms are eliminated. Let me see how it will be. So this is the equation we are using for the power generation for ith plant. Now see here, the denominator may include, so in the denominator we have only 2 gamma I, but I already said that the B coefficient term should not act a vital role in this equation. Just we have to use for the balancing purpose for that derivation of power generation formula. So here in the denominator it has only 2 gamma I. So we can including the B coefficient, how it will be means, see here. The denominator may include B coefficient with economic dispatch multiplier. So this is the term we are including here. Why lambda is came is, so here they mentioned with economic dispatch multiplier. So lambda is called as incremental fuel cost or economic dispatch multiplier. From this equation, this is for, so in this method also we are going to solve the problem in iterative method. First initially we have to consider one lambda value. If it is not satisfy the power balance equation, again we have to update the lambda value. Again we had, so it is keep on going to increase. That's why I am writing this equation for the kth iteration. So we had, so for the first iteration we have to keep 1, 2 like that. So this is the power equation for the ith units, power generation equation. So represented it is equation 6. So for solving the problem, what are the formulas we have? What are the formulas we have to know that? First of all, we have to assume the lambda value, and based on the lambda value, we have to find that Pg1, Pg2, Pg3 values, and so you have to know that these formulas also. After finding that, you have to satisfy the energy balance equation. If it is not satisfied the energy balance equation, you have to update the lambda value by using the delta lambda. So these are the formulas you have to know. In this case, we already found that lambda equation and PG1 equation. Now we have to find that delta lambda. Let me see how it will be. We can find that value. Right. So after finding the PI value, that is power generation with respect to the ith plant, that is 1, 2 like that. After that, we have to satisfy this power balance equation, that is this one. And here the PGI is enter this. So after PGI value, you have to substitute here and you have to check whether the energy balance equation is satisfied or not. If it is satisfied, then your lambda value is correct. If it is not satisfied, you have to go for the updating process. That updating process should is like this. So here f lambda k. So this entire term is called as f lambda k, and why I am assuming here means for updating the lambda. So how we can update and which formula we can use for the updating the lambda value. That's why I'm considering this entire term is f of lambda power k, and in right side it is common pd plus pl. So power loss is again difference. Why? Because in the problem they will give power loss in one equation. So PL is equals to 0.028 Pg1 plus 0.032 Pg2 plus so like that they will give. So while changing the Pg1, Pg2, Pg3, the power loss value also changes, right? So that's why the power loss value should be changed based on the iteration value and Pg1 value, Pgi values. And here it is constant. So while doing the problem, you can get the clarity what is how the power loss equation will be represent, how they will give, what is the process we have to solve the problem. Like that you can know that while doing the problem itself. Next, see while incrementing that, while updating the lambda, we have to use these following steps. This is the equation we have to use for the updating process, and the left side the big term is considered as a f of lambda power k. Now if you want to expand, if you want to updating this lambda value, we have to use the Taylor series expansion. So already we did some in different derivations. Taylor series it is used for the iteration purpose, and in this case we have to neglect the higher order term. Then only we can derive the equation in easily. Now from this equation I can write for updating purpose. So this is the old one, and this I have to update the lambda value. If you add this two, then you can get the lambda value, right? So what we did in last, the same thing. Finally the delta lambda k. So there are certain steps are there, but there is no need. So just you can go through the material, then you can get that how the derivation is came. So delta lambda k is equal to delta pk divided by. So this is the equation of for the updating of lambda. So delta pk divided by summation of pga. So here this is the incremental cost equation, right? So you can use this formula for updating the delta lambda, right? So finally the equation should be like this. So this is the old one. If the power balance equation is not satisfied, we have to update. We have to go to next iteration, that is the k plus 1 iteration. In that iteration, we have to add what is the changes happening in the lambda value. So this is the iteration 1. Let's consider this iteration 2. For iteration 2, you definitely update the lambda value by using this equation. And after that, so in previously the delta pk is there, right? That is the numerator value. This one. So you can find this value by expanding this sum. So if we add 3, you will get the 3 terms. But how we can find this value means by using this one. So this is the formula we have to. So this delta pk is called as a power balance equation. And see here, what is the condition for this means the process is continued until delta pk is less than specified accuracy. So specified accuracy is nothing but the value should be approximately equals to the 0. Sometimes you will get 0.001. So sometimes you will get 0.01. So at that time it is okay to satisfy this value. So it never sometimes it never get the 0. So sometimes they will get 0.01 like that. So at that time you can consider that lambda is perfect value. Now, this is the way we can find the delta pk for different iterations. So if it is iteration 1, you have to use that value for iteration 1, pg1 plus pg2 plus pg3, what we found in the iteration 1. If it is iteration 2, you have to find that we have to use the values with respect to the iteration 2. So are you clear about the update value of lambda? Next. Now, what are the steps we have to use? So now I'm showing the formulas, exact formulas, what we have to use that use in the iterative method. So based on this topic, the problem should be asked like this. So it has the 3 power plants having that maximum demand so on. So definitely if they will ask they will give the power loss equation, then the problem is belongs to the iterative method, and that is belongs to the third method. So if we are not, if they are not giving the power loss equation, it belongs to the second method of scheduling. So just remember that one, two things. One is if they are giving the PL, that is power loss equation, they will give power loss equation here in the question itself. Then it belongs to the third method. Now we'll see that what are the step by step what we have to find that. First, first we have to assume the lambda value. While assume the lambda value, we have to find that pg1, pg2, pg3. Already these values are, you know that lambda 1, that is gamma 1, beta 1, and lambda. So here you can take b11. So b11 they will give that b11, b12 they will give the value of itself. So this I will tell you how it will be find in the question. Okay, so this is the first step. We have to assume the lambda value. Now by using the lambda value, we have to find that pg1, pg2, pg3. After finding that, we have to calculate the power mismatch. So we have to satisfy this equation, pd plus power loss. So after finding this pg1, pg2, pg3, you have to substitute these values in the power loss equation. Then you will get one power loss value minus of pg1 plus pg2. So after substituting these all values, the delta p should be nearer to the 0. Then only you can consider as a lambda value is the exact value. If we are not considering, if you are not obtaining that equating 0, again you have to update the lambda value by adding lambda a plus delta lambda. How we can find the delta lambda means by using this formula. So this is the formula we can use for the finding the for updating purpose. So here the delta p power k can be defined by. So what we value found in this equation. Suppose if you are obtaining here a minus 44. So this is the minus 44 we have to use here. So here minus 44 divided by, if you expand this one, you will get the answer. So after this lambda, you had, so suppose at initially we are assuming that lambda equals to 6. After finding this value, you will get 0.48. So finally, our updated value is 6.48. Again, we have to solve same thing until the delta p should be equals to the 0. So this is about derivation of optimum dispatch optimum generation control with including transmission losses. So this is about today's class. Now tell me that if there is any difficulty you are facing in this derivation, I will again explain you. Are you guys clear about this? Venkatesh. 202. Just reply in message itself. No need to talk. So I'm calling somebody, right? They have to reply me. Then only I can consider you are presenting my class. Right. What is the difference that is, we discussed two derivations, right? One is not including losses, second one is including losses. In that, what are the there is some formulas are included. What are the formulas are including in this derivation itself? So మా టూ డెరివేట్ చేసాం కదా, ప్రీవియస్ డెరివేషన్ లో లేని ఫార్ములాస్ ఈ డెరివేషన్ లో ఏమేమి వచ్చాయో చెప్పు ఒకసారి. కనీసం ఏమి టర్మ్స్ యూజ్ చేస్తావు ఇక్కడ, కొత్త టర్మ్స్? క్రాస్ లాస్, రైట్. ఇంకా సో ఇక ఈ డెరివేషన్ లో మీకు 3 2 మార్క్స్ క్వశ్చన్ చెప్పాను. వన్ ఈజ్ పవర్ లాస్ ఈక్వేషన్, క్రాస్ లాస్ ఫార్ములా, పవర్ బ్యాలెన్స్డ్ ఈక్వేషన్. సో 2 మార్క్స్ బాగా జాగ్రత్త నేర్చుకోండి. సో మీకు ఈ యూనిట్ నుంచి 2 మార్క్స్ కనుక వస్తే, ఒకటి గ్రాఫ్ నుంచి వస్తాయి. డ్రా ద హీట్ రేట్ కర్వ్, డ్రా ద ఇంక్రిమెంటల్ ఫ్యూయల్ కాస్ట్ కర్వ్, డ్రా ద ఇన్పుట్ అవుట్పుట్ క్యారెక్టరిస్టిక్స్ ఆఫ్ ఏ థర్మల్ ప్లాంట్, హైడ్రో పవర్ ప్లాంట్. సో డెఫినెట్ గా ఒక క్వశ్చన్ వస్తుంది ఆ గ్రాఫ్ నుంచి, ఓకేనా? తర్వాత ఈ 2 మార్క్స్ ఏమవుతుందంటే, రైట్ డౌన్ ద క్రాస్ లాస్ ఫార్ములా, రైట్ డౌన్ ద లాస్ ఫార్ములా, రైట్ డౌన్ ద ఇంక్రిమెంటల్ ఫ్యూయల్ కాస్ట్ ఫార్ములా, రైట్ డౌన్ దట్ total cost formula. So you should have to know that all. So again I'm telling you that what are the formulas till now we discussed. First one is CT, so that is the total cost. So total cost in the form of alpha I plus beta I PGI plus gamma I plus gamma I PGI square. From this equation you will get that incremental fuel cost equation. After that, power loss equation in two forms. One is quadratic form, another one is cross loss formula. That is included that linear term and constant term. And one more thing, in this equation we found the that is incremental equation, including incremental fuel cost and incremental loss formula. సో మనకి ఇక్కడ ఈ లాంబ్డా వాల్యూలో 2 వచ్చాయి. మామూలు జనరల్ గా ఏముంది, లాంబ్డా ఈజ్ ఈక్వల్స్ టు ఇంక్రిమెంటల్ ఫ్యూయల్ కాస్ట్ అడుగుతాం, కానీ ఇక్కడ మన లాసెస్ కూడా ఇంక్లూడ్ చేసాం కాబట్టి ది 2 టర్మ్స్ ఆర్ ఇంక్లూడింగ్ ఇన్ ద లాంబ్డా వాల్యూ, ఓకేనా? తర్వాత లాస్ట్ డెరివేషన్ కి కామన్ ఏంటంటే కండిషన్స్, 2 కండిషన్స్ ఉన్నాయి కదా. ఫస్ట్ కండిషన్ ఏంటి, డోఎల్ బై టో బీజీఏ చేసిన తర్వాత అండ్ ఇట్ ఈస్ ఈక్వల్స్ టు ద 0. తర్వాత డోఎల్ బై డో లాంబ్డా ఇట్ ఈస్ ఈక్వల్స్ టు 0. సో ఈ ఫార్ములా చేసిన తర్వాతనే మనకు ఈ లాంబ్డా వాల్యూ వచ్చింది, ఓకేనా? సో దాని తర్వాత లాంబ్డా వాల్యూ ఎలా అప్డేట్ చేయాలి. సో ఇంకోటి వచ్చేసి దీనిపైన కొంచెం ఓ ప్రాబ్లం ఉంది. సో ఇట్ మేక్ లెంతీ అనమాట. సో మీకు రేపు క్లాస్ లో వచ్చేసి ఈ డెరివేషన్ పైన ప్రాబ్లం చెప్తాం. సో ఆల్రెడీ మీకు 80% టాపిక్ కవర్ అయిపోయింటాయి ఫస్ట్ యూనిట్ నుంచి, ఓకేనా? సో ఇంకా మీకు ఈ రేపు ప్రాబ్లం అయిన తర్వాత 2 టాపిక్స్ ఉంటాయి. ఆ 2 టాపిక్స్ తర్వాత ప్రీవియస్ క్వశ్చన్ పేపర్స్ లో ఫస్ట్ నుంచి ఏమేమి క్వశ్చన్స్ ఇచ్చారు, ఆ క్వశ్చన్స్ ఎలా రాయాలో మీకు ఎక్స్ప్లెయిన్ చేస్తాను, ఓకేనా? సో యూ జస్ట్ గాట్స్ అవేర్ అబౌట్ దిస్ 2 డెరివేషన్స్. దయచేసి 2 డెరివేషన్ బాగా నేర్చుకోండి. కంపల్సరీగా ఒక క్వశ్చన్ వస్తుంది మీ ఎక్స్టర్నల్ ఎగ్జామ్ కి, ఓకేనా? సో డోంట్ బి నెగ్లెక్టెడ్ దట్. సో లాస్ట్ టైం కూడా మీరు నెగ్లెక్ట్ చేసినా కాబట్టి ఎగ్జామ్స్ ఉండవని బ్లేమ్ పడకండి. ఎగ్జామ్స్ కంపల్సరీగా ఉంటాయి, ఓకేనా? సో ఇప్పటి నుంచి మీరు ప్రాక్టీస్ చేసి ప్రిపేర్ అవుతానండి. ఎగ్జామ్స్ టైంలో ప్రిపేర్ అయితే హైలీ ఇంపాసిబుల్, ఓకేనా? సో అది. సో ఇంకేమైనా డౌట్స్ ఉన్నాయా మీకు? Do you have any doubts? Satish, Vinita. ఏమైనా డౌట్స్ ఉన్నాయమ్మా? అర్థమైందా క్లియర్ గా? సో మీకు స్టెప్ బై స్టెప్ నీట్ గా ఫామ్ చేసి ఇచ్చాను, Okay, I will tell you that I will send you this PPT also. You can cross check it. So now material ki ee PPT cross check cheskondi. So everything I already sent to you. 5 minutes material పంపించాను, 2 months పంపించాను, previous question paper పంపించాను. తర్వాత ఏ రోజు ఆ రోజు క్లాస్ మీకు లింక్ పంపిస్తున్నాను, PPT పంపిస్తాను. సో నా వైపు నుంచి 100% స్టఫ్ మీకు ఇస్తున్నాను. బట్ యు హ్యావ్ టు రెస్పాన్సిబుల్ యువర్ సెల్ఫ్. ఓకేనా? సో జాగ్రత్తగా ప్రిపేర్ అవ్వండి. సో మీరు ఇప్పుడు ప్రిపేర్ అవుతానే అక్టోబర్ లో జరిగే ప్రీవియస్ సెమిస్టర్ ఎగ్జామ్స్ రాయగలుగుతారు, లేకపోతే బడ్డంగా ఫీల్ అవుతారు. ఓకేనా? సో ఇవి ప్రిపేర్ అవుతావు, ఆ సిలబస్ కూడా కవర్ చేసుకోండి. సో ఆ క్లాస్ రూమ్ నుంచి మీరు డౌన్లోడ్ చేయలేరు, జస్ట్ మీరు చూసుకోవచ్చు. ఎందుకు మీరు ఆ విధమైన మెథడ్ చూస్తానంటే మీ స్టోరేజ్ ఇబ్బంది కాకుండా ఆ విధంగా చేస్తాను. ఓకేనా? సో మీకు జస్ట్ మీకు వాట్సాప్ కావాలన్నా వాట్సాప్ చేస్తాను, నో ప్రాబ్లం. సో మీకు ఆ స్టోరేజ్ బటన్ కాకూడదని నేను ఆ విధంగా చేశాను. ఓకేనా? సో మీకు కావాల్సింటే సపరేట్ మెటీరియల్స్ 5 యూనిట్స్ మీకు సపరేట్ గా వాట్సాప్ ఫైనల్ గ్రూప్ లో పెట్టేస్తాను. సో మీరు అక్కడ డౌన్లోడ్ చేసుకోండి. ఓకేనా? Right. So today I'm going to end this class, and tomorrow you should have to be. So ఎందుకంటే లాస్ట్ క్లాస్ లో ఎవరు సబ్మిట్ చేయాలి మీ నోట్స్ ని, రేపు మాత్రం కంపల్సరీగా ప్రతి ఒక్కరు నోట్స్ ఉండాలి, క్యాల్కులేటర్ యూజ్ చేయాలి. సో క్లాస్ అయిన తర్వాత మీరు నోట్స్ రాసిన తర్వాత అది నాకు వాట్సాప్ పంపిండి. సో దెన్ ఓన్లీ ఐ కెన్ నో దట్ హూ ఈస్ లిజనింగ్ మై క్లాస్ అండ్ హూ ఇస్ నాట్ లిజనింగ్ మై క్లాస్. ఓకేనా? సో డోంట్ టేక్ దిస్ సీరియస్. So I'm going to end this class. Thank you.